Okay, these are some of the Are You Ready for Calculus problems. Number one, this is binomial over trinomial, x cubed minus 9x over x squared minus 7x plus 12, as you can see. And hopefully you could download these. I put two different files in the folder, and hopefully one of the two will be able to download, and you can print these out. It's a little bit easier to look at them that way. And what we see is we have a common factor of x in the numerator, so I can factor out an x, and I end up with x squared minus 9, which ends up factoring to be x plus 3 times x minus 3. And the denominator is a trinomial, simple trinomial. Here I kind of draw these out step by step. I had already done these, so this is why they're already finished. But this tells me that these signs would be the same, and this tells me what they are. They're both going to be negative. I'll multiply to give 12, 3 and 4, and if the signs are the same, the sum will be this number here, which is 7, so that works out. Okay, multiply to give 12, their sum is 7, and the signs are the same. They're both negative. That's how we analyze those simple trinomials. And here we have an x minus 3 that is common, so we could cancel that out, and we end up with this. And sometimes these forms are fine. You look at the answers, and lots of times in calculus what we have to do is we have different forms for answers, so we've got to doctor them up. And here we just have to multiply this out to get this in the form that they want. So we do have an algebraic equivalent there. Okay. All right. Now remember, you also they don't require this in these particular problems, but there's understood restrictions on the domain or the values that x can be. X cannot be 3 or x cannot be 4, otherwise we'd have 0 in the denominator. So sometimes they ask you to write those restrictions. They didn't here, so we're okay. All right, the next one. And started trinomial over trinomial. Now here I noticed that I had a common factor of x, so I kind of factored that out here to save a step. And then I got two simple trinomials. So the top factors to be x minus 4 times x plus 2, and the bottom factors to be this x, and then this simplifies to be x plus 2 times x minus 4 factors. And hopefully you know how to factor your simple trinomials without a problem. And then we have a common factor of x plus 2 in the top and bottom, so we cancel those out, and this is what we end up with. That's the form that they had. Now you might say, well, can I factor this out? You could factor it and have x times x minus 1, but this is the form where they had the answer, so you just match that up. Okay? Okay, letter C. Now letter C is a complex fraction. We have a fraction in the top. Actually, we have two fractions in the top, two fractions on the bottom. So whenever you have a fraction in the numerator, the denominator, or both of a fraction, it's called a complex fraction, and we simplify these. Now, in Algebra 2, the way we used to do these is we would try to get one fraction in the top, one fraction in the bottom, and then change it to a division problem, and then invert and multiply. But we see so many of these in calculus that we kind of take a shortcut. We introduce a shortcut. And I learned that in calculus. Sometimes I teach it in pre-calculus to get a little jump on the game. Whenever you have a complex fraction, the easiest way to clear it in one step is to multiply the top and the bottom by the least common denominator of all the fractions. X squared 25, the least common denominator is 25x squared. So if I multiply the top and the bottom, it means every term in the top, every term in the bottom by that LCD, watch what happens. When I multiply 25x squared times x, the x cancels, I got 25x. Here the 5 cancels, 5x squared. Here the x squareds cancel, 25, and here's the 25 cancels, x squared. No more complex fraction. Then all we have to do is factor the top and factor the bottom. Here I can factor out a 5x, leaves me with 5 minus x. Here I can factor this as a difference of perfect squares, 5 plus x times 5 minus x. The 5 minus x's cancel, and presto, we're done. So it's real easy. It's a nice method to know. Multiply the top and the bottom by the LCD, and then you're home free. And letter D, the last one, number 1. This is another complex fraction, and this is like 9 over 1, 3 over 1, 1 over x squared, 1 over x. The LCD is x squared, so I multiply the top and the bottom by x squared. In the top I have 9x squared. Here these cancel, minus 1. Here I have 3x squared, and then 1x cancels, so I have x. And again, I got the difference of perfect squares, 3x plus 1, 3x minus 1. Here I can factor out an x, And I get 3x plus 1, and then the 3x plus 1's cancel, and there's your answer. So again, that technique of multiplying the top and the bottom by the LCD is very important. So make sure you kind of take note of that. Okay, number 2, we've got some radical terms we have to simplify. And again, if we have a radical in the denominator, that's not usually acceptable in what we call simplified form. Although sometimes, that's okay as we go on. But in this case, we have a binomial, and it's containing radicals, so we usually use the conjugate to take care of these radicals, and the conjugate is just the same binomial, but with the opposite sign in the middle. So I multiply the top and the bottom by the square root of 3 minus 2, which is the conjugate of this square root of 3 plus 2. I'm sorry, square root of 3 plus the square root of 2. And what happens on the top, I've got 2 times this. That's no problem. We'll just leave that. And then here, this is basically the same as a plus b times a minus b, which is a squared plus b squared. So the square root of 3 squared is 3. The square root of 2 squared is 2. 3 minus 2 is 1. And we're done. Okay. All right, the next one. Same thing. 4 over 1 minus the square root of 5. The conjugate would be 1 plus the square root of 5. So I multiply the top and the bottom by that conjugate. Okay, and then I have 4 times that. And then this again is a plus b times a minus b is a squared minus b squared. 1 squared is 1. The square root of 5 squared is 5. 1 minus 5 is negative 4. And negative 4 goes into 4 negative 1 times. And if I multiply by negative 1, you could have left the negative 1 out in front, but this was the answer they had. So I matched the forms. Okay? All right. Now, letter C. This was a little trickier because we had 2 radicals on the bottom, and not just like this, because we also had a number. So we had a whole number and 2 radicals. So this is a little more complicated. So the way we kind of deal with this is I group these so I could get rid of 1 radical at a time by using conjugates. So this is a little bit more of a complex binomial because I got 2 terms in the first term of my binomial, and then 1 term in the second term of my binomial. But I can identify the conjugate of this by being the same thing except making that a positive sign. So if I multiply the top and the bottom by the conjugate of this sort of complicated binomial, I'm going to be able to get rid of 1 radical, and then I'll try to get rid of the other radical. So this one we have to do 1 radical at a time, primarily because we've got 3 terms instead of just 2, like example A or problem A. Okay. So when we do this, now the top's going to get messy, so it's just going to be those 3 terms. And the bottom, basically, it's just this squared, first term squared, minus the second term squared. So this is my top, and this is my bottom. Now I've got to square that out, but I can use a binomial squared formula we learned back in Algebra 2. 1 squared is 1, plus twice the product is 2 times the square root of 3, and then plus the square root of 3 squared, which is 9. I'm sorry, the square root of 3 squared, which is 3, minus the square root of 5 squared, which is 5. Top stays the same. And I can simplify this. 1 plus 3 is 4, minus 5 is negative 1. So this is what I end up with. Okay. Now, I got a nice simple binomial in the bottom, and I can use the conjugate quite easily, which is just going to be a positive. 2 times the square root of 3 plus 1. Now, the top's going to be messy because I've got 1, 2, 3 terms. By 2 terms, I'm going to have 6 multiplications. Lots of ways to do this. What I do is I multiplied every term up here on the top by the 2. So that's 2 square roots of 3, and then 2 times the square root of 3 times the square root of 3, which is 3. And then 2, and then the square root of 3 times the square root of 5 is the square root of 15. And then I multiply everything by 1, which is just the 1, square root of 3, square root of 5. So those are my 6 terms on the top. In the bottom, again, it's the first term squared minus the second term squared. So 4 times 3 minus 1. And we can simplify the top by combining like terms. 4 times 3 is 12, minus 1 is 11. And then when I simplify the top, I took my numbers. I had 2 times 3 is 6 plus 1 is 7. And then I had 2 square roots of 3 plus 1 square root of 3 is 3 square roots of 3. And then the square root of 5 and the 2 square roots of 15 were just kind of left alone because nothing to simplify those with. Alrighty. And the last, that was it. Okay. That helps.